righty, hello. So we're looking at who would like to give us the heads up. So the first bit, we all agree, 1 plus I in polar form. So what was 1 plus I in polar form? Hit me. So it's got to be root 2 pi on 4, which we can get really simply by going, yes, it's across 1, it's up 1. We know that it's splitting right in half, so we should know that that is pi on 4. Alternatively, if you were tired, if you didn't think, you could use your calculator, right? We've got technology under control. Right, so then, hence, write z to the n in polar form, so we're happy that this would then be when you are using de Moivre's theorem, could I ask that you actually say that you have? Okay, so just a little to the side saying that you have. So we're getting used to that, explaining why we're going through and saying certain steps, okay? All right, all good? Part B. This was the bit that we were asking about. So, part B, find all values of n for which z to the n is real. Sound like I felt like I said Israel there, but is real. Now, without giving the answer away, who could give a clue as to what they should be thinking of? And remember, we've got z is cis theta. Who can give a clue? Wait, I'm coming. Yes, you're going to say anything to Karen and also Skyby, who's away, but not away for 5 weeks. Anyway.
Hello, Karen, and
Sky.
Yeah, and Sky, sorry. Z to the n would be real when the...
Oh, not giving it away. Hint.
Fine. When there isn't an imaginary component.
There isn't, okay, that's good. So, what does cis consist of? What is cis? Yeah. So, we've got cos theta plus I sine theta, right? I would probably not write that. I would probably say this is cis n theta, and so that would be cos n theta plus I sine theta, because I don't want to expand anything to the power of n. Do we agree? So, going back then to our little situation here, we have cis n pi on 4. I'm going to ignore the modulus. Am I allowed to do that? Yep, because that's not going to have any bearing on whether it's real or not. So what did I just say? Cis n pi on 4. So according to this, that's going to be cos n pi on 4 plus I sine. That hurts me to write sine n pi on 4. Couldn't they use a different letter? 4. So if we want it to be real, as Dylan said, the imaginary part must equal 0. Do we concur? So what's my imaginary part? Here, right? So the imaginary part, the I tells us, the I's have it, the I tells us that it's imaginary, so we basically want sine n pi on 4 to equal 0. That's domino effect now, right? So when is sine going to be 0? 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, etc., yeah? So that's when n pi on 4 equals k pi? Equals k pi. Chi? Oh my goodness. Chi. K can't be anything, can it? Like it can't be 0.5, it can't be a third. K has to be an integer. That's a good question. Does it have to be positive? No, it can keep going the other way, right? So it can be minus pi, minus 2 pi, minus 3 pi, and so on. Okay, but what were we actually asking? What's the question? I get a bit carried away, so I always have to go back and check. Right, check your find all values of n. So let's rearrange this to get n. Oh, well, the pi's will cancel, yeah? Times by, was that right? There you go. And then, of course, when you want to do this one, for when it's purely imaginary, well, clearly that's when the real part has to equal 0. And so it's going to make you stop and think about when cos theta is equal to 0. So again, I don't know how do you guys look at the unit circle? I am a graph kind of girl. So I know cos theta is 0 at pi on 2 and 3 pi on 2. Or you guys might be, girls, might be a look-up table kind of people. Up to you. But you need to know, it's one of just those things, when sine and cosine is 0. Yeah? Okay, if z equals cis theta, prove that z squared take 1, z squared plus 1 equals I tan theta. We've got two options. When we've got cis theta, we can either think about messing around with the properties for cis theta. So cis theta times cis phi equals cis theta plus phi, whatever. Don't think that's going to help us here. We've got de Moivre's theorem, right, with the whole squared thing. And then we've also got the fact that cis theta is cos theta plus. Yeah. All right, so let's have a look. Left-hand side. Z squared take 1 all over z squared plus 1. So that becomes cis theta squared take 1 all over cis theta squared plus 1. So you have got a decision to make. Do you want to put in the brackets cos theta plus I sine theta, or do you want to use de Moivre's theorem so that we then have cis 2 theta?
Considering that it's in the theorem
Exactly.
section.
Considering it's in the de Moivre's theorem chapter exercise, I think that would be the way to go. So we will write this. I will stop in a minute because I know you're probably madly scribbling, some of you, but once we've got this, again, we don't really know what the answer is, but you've got to put something down on paper. So we could, out of desperation, say that this is cos 2 theta plus I sine 2 theta take 1. Why are people talking? And then we've got cos 2 theta plus I sine 2 theta plus 1. And now it's decision time again. But one of the decisions I hope you are looking at is when you see cos 2 theta and sine 2 theta, we're thinking of our double angle formulas. Yeah? So sine 2 theta, and I'm a little bit wary with this one because it's making it bigger. But anyway, I've got 2 sine theta cos theta, and you guys are going to have to help me out now. Who's got their formula sheet handy? Because I never remember. So cos 2 theta, is it cos squared take sine squared?
Yeah.
So we've got cos squared theta take sine squared theta. What else have we got?
I've got the 2 cos squared theta take 1.
And I know this one now. 1 take 2 sine squared theta. Now, these ones make me feel a little bit happy.
Because they can cancel the ones.
Right. So get that down. See which one of these you're going to sub. And then whenever you've substituted, you always want to look for, like, tidy up, see if anything cancels, but then always look for a common factor. So go your hardest. Let's see what happens. Right, so we're choosing the 1 minus sine squared theta because I want to, oh, and by the way, what's sine 2 theta? Might as well sub in while we're here. you've got to keep the I, yep. So that's going to be 2 sine theta cos theta, and then this -1 is going to cancel out with this one. Okay, then we're going to do the same to the bottom, but we're going to choose this one. A little bit worried. So they cancel, they cancel, they cancel, they cancel. Yeah, have we got a common factor?
Yes, and then sine is a common factor on the top row and cos is a common factor.
Okay. Still not overly confident, but anyway. Oh, could I pull out? Can I pull out 2 sine? Yeah. I'm going to go I cos theta two cos so what do I got? Cos theta is it plus I sine? Okay, so I'm starting to get a little bit excited. It looked a bit ugly, but keep your eye on the prize for the right-hand side. What did I want? I tan. So part of me is going, well, this is looking sharp because the 2's will cancel. I've got sine over cos, which is awesome because that's the tan theta, but how is this meant to be I? Do you notice, what's this? That's just cis. But why is it cis over cis? So really what I need is I need to pull out I as a common factor, isn't it? On this top line here. So if I pull out I get cos theta. But what do I have to have here so that when I expand it I get minus sine theta? Don't I have to have plus I sine? Because what's I times I? What is it? It's I squared. Look at Hamish, she's so happy. Right? It's B minus. But I didn't see that originally, right? I'm looking at my right-hand side and I'm going, I want it to be I tan theta. I've got my tan. How on earth is this meant to be I? And then I look at the bottom. Oh, yeah, that's cis theta. And then it sort of flows from there. So you're not going to see, well, you might see things straight away, but play around, right? So then I've got cos theta plus I sine theta. If you wanted to, you can convert that to be cis theta if you really wanted to, but I'm done at this point because I just want to get out of here and go cancel, cancel. So now I've got tan theta times I, which is I tan theta. In order to do question 9, you need to pay really close attention to the example. Okay? So notice, by considering, deduce the double angle formula for cos 2 theta and sin 2 theta. Kids at the back. So we've got 2 things going on here. They've basically looked at cos 2 theta and they've seen that they can express it in 2 different ways. They can do this with just breaking it up using polar form. Yes? And then they can use de Moivre backwards to say 2 theta means it's squared. And they can say, well, let's go back and actually square. And they're going to expand this, and then they're going to equate the real and the imaginary parts. And that's how they end up with cos 2 theta equals the real part here, and they get their formula. Does that make sense? So now they're going to ask you to do it for cos 3 theta, cis 3 theta. So let's have a look at the first part of number 9. Oops, did that go up nicely? Okay, so what I'm going to ask you to do is 2 things. when we see this, what we are trying to do is we are going to consider cis 3 theta. Yeah? And do we agree that cis 3 theta equals cos 3 theta plus? I'd like to think we all agree with that, yes? But we also know that cis 3 theta could equal cis theta cubed. Yeah? And that means that we are going to take cos theta plus I sine theta, and we're going to cube it. And I'm going to be very, very happy because I'm going to use Pascal. I love a good Pascal usage in class. So I'll just give you a moment to write that. So Pascal, that means this is going to be 1 cos cubed theta, yes, plus 3, now we square cos, and we just multiply by I sine. Oui? The next one will be 3 lots of just cos, right? Cos cubed, cos squared, cos, but this will now be careful, because we're squaring all of I and sine. So it becomes I squared and sine squared, and then plus I cubed sine cubed theta. So remember, what we're aiming for is we don't need to like simplify and get rid of the cos cubed and whatever, because go back and look at, I'm very excited, there's a cos cubed here, but then I get a little bit sad because it's 4 cos cubed and I haven't got 4 cos cubed here. But that's okay. We'll get there. I've got the 1. That's a start. So we're going to go cos cubed theta plus, not much can be done with that. So would you agree that this part is imaginary and we can't do much more? However, look at the next term. It's got an I, but would you classify it as being imaginary? No, because I squared is minus 1. So this now becomes minus 3 cos theta sine squared theta. And then my imaginary parts become I 3 cos squared theta sine theta, and what's I cubed? It's not -1. So I cubed, do we agree, is I squared times I? I squared is -I, so it's minus I. So that's going to be minus I sine cubed. I'm a little bit happy with myself and go, yeah. This is pretty good. So what we're saying is that this is the real part. So, watching? So technically this is equal to cos 3 theta, because that was the real part. This was my real part here. So we're saying cos 3 theta equals this, but this isn't this. What do you notice about what we're trying to make it prove and what we have so far? We haven't just got a sine, we've got a sine squared. If only there was something that we could replace sine squared with. Say it loud, say it, wait, I'm coming to you, and Pascal is coming too. Yes?
Cos squared take 1.
Almost.
Oh.
1 take cos squared.
Yeah.
That's what you meant.
That's what I meant to say.
Right? So replace sine squared with 1 take cos squared, and then over here, look at what you're meant to be doing. The i's are no part. Yeah, common factor. The i's tell you that that's the imaginary part, and then its role is over. So notice there's no i's in here. It'll just be, here's your imaginary part here, sine 3 theta has to equal this. But again, no cos squareds in here. So what can we replace cos squared with? 1 take. Okay, go forth. So our real part, right, is right at the beginning up here. This was our real, cos 3 theta. That's going to equal this real part here. Cos cubed theta minus 3 cos theta sine squared theta. But that's not what they wanted us to prove, right? What they wanted us to prove, who is they, who knows, is this, right? And we said the difference was that ours has a sine squared in it and theirs doesn't. Easy fixed. Let's replace, get rid of the sine squared. And we get rid of it because we know that sine squared is 1 minus cos squared. So we're going to have cos cubed theta minus 3 cos times 1 is minus 3 cos theta. What's a negative times a negative? Positive. Hamish is going to give me a massive big smile in a minute because what's cos theta times cos squared theta? Cos cubed. And lo and behold, what's 1 cos cubed plus another 3 cos cubed? It's 4 cos cubed, which is what we wanted. Right? To do part B, it's very hard to talk when you guys are chatting. To do part B, we're looking at equating our imaginary, right? So up here, what's our imaginary? Sine 3 theta. I'm ignoring the i's. The i's tell me that it is imaginary. So, oops, that wasn't it, was it? Sine 3 theta. What's my imaginary part over here? Well, it's this. And it's this. So cos squared theta sine theta. Tyson, I hope you're getting this. There's a 3 in front of the cos. Thanks, Dylan. Right? Once again, if I can compare what they wanted in part B, there was no cos. So replace our cos squared with 1 take sine squared. Expand, gather your like terms. It should pan out. But, oops, now, hence find tan 3 theta. So get a nice big page. Right? What is tan 3 theta? Is it not sine 3 theta over cos 3 theta? And we have just got expressions for sine 3 theta and cos 3 theta. So sub them in, see what you can do. So far we've got that. Yeah? And in terms of tan only, yeah, okay, good luck. Good luck to you. Do your thing. No. Okay. I see common factor. What's your common factor? Sine on the top. So sine theta, we've got 3 take and denominator, oh, it's cos theta. A little bit happy because what's sine over cos? That's nice. Okay, that's nice, that's nice. So far so good. So I've got tan theta. Okay, now we're in trouble. Okay, so we have got some choices to make here. And a couple of choices are, well, we could do what we did last time, and wherever the sine squared is, we could replace it with 1 take cos squared. But what would that end up with? We would end up with 3 take 4, I better write it. So we end up with 3 take 4 plus 4 cos squared, and we're just sort of going to go into a bit of a loop. Oh, good Lord, that's a 4. Because downstairs you're going to get the same sort of thing, and then you're going to have, if you replace cos squared with sine squared, you're going to have the same thing, and you're just going to have something sine squared. So that's not that good. And think back to, what is it that we're trying to do? Manzi, we're listening? What is it that we're trying to do? We're trying to express it in terms of tan. Tan only. And I'm thinking, yeah, tan is sine over cos. So this is a little bit, I guess it's a tool that I have in my belt that you're not sure of quite so much because we haven't done a lot of the tan stuff. But think of the 3. What if I replace that with 3 sine squared theta plus cos squared plus 3 cos squared theta? Now, I don't know, but it is a technique that sometimes, because I just think with this, I think we're going to go into an infinite loop. We might go into a loop with this. Not quite sure. Like when I do this, I'm quite prepared to go, oh, that didn't work, try something else. I am not of the mindset, oh, I'm not going to put anything down on paper just in case it's wrong. I am more than used to getting things wrong. And suddenly, I'm not feeling so confident anymore. Never mind. Don't pack up. Do you remember why I said to do this? Because tan is sine over cos. What's going on here? I can now, in one swift move, I can get rid of all the coses and the sines. What do I have to do to get rid of the coses and the sines? No, when you said cancel, I can't actually cancel anything. No common factor. I want to divide by something. I'm going to divide the top and I'm going to divide the bottom. And your clue is tan, tan. How do I get tan from the sine squared? Divide by cos squared. Oh, and what's cos squared divided by cos squared? 1. So if I divide this by cos squared, and what I do to the top, I do to the bottom, I reckon everything's going to disappear and I'm going to be left with just tans and numerals. So I've got tan theta. Brody has just given me a face. Shh. 3 cos squared divided by cos squared is 3. Agreed? What's sine squared divided by cos squared? Tan squared. And downstairs, cos squared divided by cos squared? 1. What's 3 sine squared divided by cos squared? Well, I don't know about you, but that looks like it's all in terms of tan to me. Hey Karen, what to say the pyramids and the Sphinx. Hope this video made sense. Can't wait till you're back. Bye.